Good evening, everyone. So, welcome to my YouTube channel, Maths Satyam. Today, we are going to see third lecture on infinite series. Today, we will discuss convergence of auxiliary series. In last lecture, we have discussed given the definition of auxiliary series. So, auxiliary series given P belongs to R. It means let P belongs to R. Then the series summation 1 upon n to the power P form is called the auxiliary series. Theorem: the auxiliary series 1 upon n to the power p summation is convergent if you are taking p value greater than 1 and it is divergent if p value is less than equal to p. So we'll prove it. So case 1 p is greater than 1. Okay. Then what is uh, what is this summation n goes to 1 to infinity 1 upon n to the power p. What is this? This is 1 plus 1 upon 2 to the power p plus 1 upon 3 to the power p, 1 upon 4 to the power p plus 1 upon 5 to the power p, 1 upon 6 to the power p plus 1 upon 7 to the power p. Okay, here we are adding two terms, then we are adding 8 terms, then we will add 16 terms, next 16 terms. So this is less than 1 plus, and this is less than 1 upon 2 to the power p 1 upon 2 to the power p. I'm taking 2 in place of 3, so it will sum will increase. So 1 upon 4 to the power p, 1 upon 4 to the power p plus 1 upon 4 to the power p, 1 upon 4 to the power p. Okay, like that. Okay, so what is this? This is 2 upon 2 to the power p, and this is 4 upon 4 to the power p. Then next will be, what will be next? 8 upon 8 to the power p will come, and then 16 upon 16 to the power p will come. It will go like that. So what is this? This is 1 upon 2 to the power p. What is this? This is 1 upon 4 p minus 1. This is 1 upon 8 p minus 1. 1 upon 6 p minus 1. 1 upon 2 to the power p minus 1. What is this? 2 to the p power minus 1 to the power whole square. This is 1 upon 2 to the p power p minus 1 whole cube. This is 2 to the power p minus 1 power 4, like that. Okay. Now you see that this series is non-negative series and this is a geometric series. This is a geometric series which common ratio 2 to the 1 upon 2 to the power p minus 1. So what is its sum? Its sum is, what will be its sum? Its sum is, what is this? 1 upon 1 minus 1 upon common ratio. What is common ratio? P minus 1. Okay. So this value is finite. So if this value is finite, this will implies, because common ratio is, what is common ratio? This is geometric series. This is a geometric series. Common ratio is equal to 1 upon 2 to the power p minus 1. that is greater than 1. So this series convergent. So if greater series is, each term of the geometric series is greater than given series 1 upon n to the power p. So if this series is convergent, okay, so this series geometric series is convergent. So this implies this n1 upon 1 to the power np is convergent. Okay, convergent by comparison test. Comparison test. Because we are grouping the term of this series. So each term be dominated by this, and this is converted into geometric series, and this is convergent. So main series is convergent. Okay. Now, case 2, p less than equal to 1. Then n to the power p is less than n for all n belongs to n. So this will implies 1 upon n to the power p is less than 1 upon n for all n belongs to n. Okay. Now summation n goes to 1 infinity 1 upon n to the power p. What is this? This is 1. Okay. 1 upon 2 to the power p plus 1 upon 3 to the power p plus 1 upon 4 to the power p. Okay. So this is so I can write it uh, 1 upon 5 to the power p plus 1 upon 6 to the power p. Hmm. So this is 1 plus 2 to the power p plus 1 upon 3 to the power p plus 1 upon 4 to the power p plus 1 upon 5 to the power p, 1 upon 6 to the power p, and it will go like that. Okay. So what is this? So in place of 1 by 2, I can put 1 upon 2 by this inequality because 1 upon 2 to the power p is less than, okay, or in place of 1 you can also put 2. Okay. Now in place of 4 I can put 4 here. I can combine. In place of 1 I can put 1 by 2. In place of 1 I also put 1 by 2. Okay. And what is this? This is also 1 upon 4 because 4 to the power p I can put like that. Then I will combine 8, 1 upon 8 plus 1 upon 8. Okay, like that. Then I will combine 1 upon 16 plus 1 upon 16 plus 1 upon 16 8 times, like that. Because in place of 1, I can put 1 by 2. 1 by 1 upon 2 to the power p. From here, it is 1 by 2 less than. 1 upon 3 to the power is less than 1 upon 4. Because it is less than 1 upon 3. So it will be less than 1 upon 4. Also, like that, I am managing these terms. Okay. So what is this? 1 by 2 plus 1 by 2. And what is this after saying 1 by 2? And what is this? 1 by 2. This is 1 by 2. Like that. Now see that this is a divergent series. This is a divergent series. Because partial sum is m times of 1 by 2 that tending to. So this implies summation n goes to 1 to infinity 1 upon n to the power p is divergent by comparison test. Okay, by comparison test. Okay, comparison test. There hence auxiliary says summation 1 to infinity 1 upon n to the power p is convergent if p greater than 1 and divergent if p less than equal to 1. Okay, so this is done. Now I would like to do one question. Note if summation n goes to 1 to is a series such that an tends to 0 as n tending to infinity, then this series 1 upon an need not to be convergent. Okay, you say this example, you say take this series 1 upon n to the power p and put p is equal to 1. P is equal to 1 is less than equal to 1. It means p is equal to 1. So this series so this implies this series is divergent, but 1 upon n tends to nth term tends to 0. Okay. So if nth term tends to 0, it does not mean that series will be convergent. It can be divergent also. But if series is convergent, then nth terms always tends to 0. But if nth term tends to 0, it does not mean that series will be convergent. Okay? So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture.